Hello everyone, I am Siddharthan. This is the 16th project video in our machine learning project series, and in this video we are going to discuss how we can build a machine learning system that can predict the amount of calories burnt during exercise. So this is a very interesting machine learning use case because like we face this in our day-to-day life regularly. A lot of people are very interested in the exercise that they do and the diet that they take and what is the amount of calories associated with them. Say for example, how much calories they intake when they eat and how much calories do they burn when they do exercises and things like that, right? And in this video we will be discussing the same, where we will be using machine learning to solve this problem. Okay, so first of all, let's try to understand more about this problem statement. So I'll be explaining you what happens inside our body when we do exercise. So what are the metabolic activities that are taking place when we do exercise. So it helps us to understand this problem statement better, and then I'll explain you the workflow which we will be following for this particular project, and then we can go to the coding part. Okay, so it will be the steps in this video. So first, now let's understand what happens when we exercise. Okay, so let's consider that a person is exercising. So he can be doing a heavy lifting like bench press, or he can be just running in a treadmill. And let's say that before 4 or 5 hours of his workout, he has taken some good meal. Okay, and the energy in this food will be used by that person, so the body of that person, to do that exercise, right? So what happens is, so let's say that the person ate something that is more of carbohydrates. So this carbohydrates will be broken into more simpler forms like glucose, and when the person do some exercises, this glucose will be broke down and it will be converted into energy using oxygen. So the muscles that are doing exercise need more oxygen, and this oxygen is supplied by blood, right? And what happens is, as the body requires more oxygen now, the heart rate, the heartbeat will increase a lot. Okay, so increased heartbeat means increased blood flow. So this increased blood flow will give more oxygen to the muscle, which oxygen, this oxygen is used to break those glucose molecules. Okay, so this is what happens. So the main thing that we can infer from here is, when we do exercise, the normal heartbeat will be more. So normally in normal conditions, the average heartbeat will be around 75 beats per minute, but when we are doing exercise, the heartbeat can be more than 100 beats per minute. So this is one of the important inference. And when this energy is used to do exercise, only a part of this energy is used, the remaining part is converted into heat. Okay, so the body temperature will increase when we do exercise, and as a result of which, in order to reduce this temperature, our body will release sweat. So this is the reason that we get sweat when we do exercise. Okay, so to cool down this body temperature. So these are some important parameters which we need. So what we will be doing is, we will be taking the parameters such as the duration for which the person is doing exercise, and what is his average beats per minute. So heartbeat, what is the average heartbeat of that person during the exercise, and what is his body temperature. So these parameters will be used, and also the height and weight of the person will be used to predict how much calories the person will be burning. So this is our problem statement. So this is what we are going to do in this particular project. Okay, so I hope you have understood what we are going to cover in this video. Now let's understand what is the workflow we will do for this project. Okay, the first step will be to collect the data. So this is the main thing about machine learning is, it learns from the data, right? So we need appropriate data to train our machine learning model, so that it can find what is the amount of calories that the person is going to burn. Okay, so the first step is getting the data. So once we have the data, we cannot feed it directly to our machine learning algorithm. So before feeding, we need to process the data. So this step is called as data pre-processing, where we clean the data and do some processing on it. So this step is called as data pre-processing, and after pre-processing, we need to do some data analysis. So this data analysis helps us to understand our data set better. So understanding our data set better, helps us to make better inference and better predictions. So the third step will be data analysis, where we will use some visualization techniques, where we try to plot the data in some plots and graphs. So once we analyze the data, the next step is to split the data set into training data and test data. So the reason for this is, so we will train our machine learning model with the training data, and we will evaluate our model. So we will test our model with this test data. Okay, so after we split the data, we need to train our machine learning algorithm. So in this case, we are going to use a XGBoost Regressor. So this is the machine learning model which we will be using in this particular case. So we will be training our XGBoost Regressor with the training data. So once we train this XGBoost Regressor, we will evaluate this model with the help of test data. So this is the workflow which we are going to follow. Here you can see here that we are using a regressor model, right? So because this is an example of a regression problem. So there are two types of problems in supervised learning. So one is classification and the another one is regression. Classification is all about classifying. Let's say that we can take a project like diabetes prediction, where we will try to predict whether a person has diabetes or not. So it is just an yes or no question, right? So those kind of problems are called as classification problem. And regression problem is something in which we try to find some particular value, particular number. So in this case we are trying to find the calories burned, right? So the amount of calories is nothing but a particular value or particular number. So this is an example of a regression problem. So in case of diabetes, we are just predicting yes or no. So those kinds of problems are called as classification problem. So as this is a regression problem, we are going to use XGBoost Regressor. Okay, so there are also other regression algorithms and the regression models. So in this case, let's use XGBoost Regressor. So with that being said, let's get started with the coding part. So before starting with the video, I'll just give you a quick introduction to my YouTube channel. So in case you are new, just watch this, and if you already know about my channel, you can skip this part and go to the video. So this is my YouTube channel, and in my channel I'm making a project based, and once you go to this channel, you can see this machine learning course curriculum. So in this video, I have explained all the modules and the videos that I will be covering in this channel. Okay, so you can download the course curriculum file from here. So in that I have mentioned all those videos, topics which I'll be covering. So you can go to the playlist section. There, if you scroll down, you will see this hands-on machine learning course with Python. So here the videos will be module wise. So the first module will be on machine learning basics, the second module will be on Python basics for machine learning, and so on. So currently we are in the fifth module, which is on the mathematics for machine learning. Okay, so every Monday evening and Wednesday evening I will be posting videos on this machine learning course order, and every Friday I will be posting one machine learning project video. Okay, so totally I will be posting 3 videos in a week, and 2 videos will be on the order of the machine learning course, and one video will be on this machine learning projects. Okay, so that is about my channel. So I'll give the link for the playlist, the machine learning project playlist and the machine learning course playlist in the description of this video. You can also check it out from there, and you can join my Telegram group and my LinkedIn. You can connect with me in LinkedIn or my Facebook group. So I'll give all those links in the description of this video. So now we will be doing our Python programs in Google Collaboratory. So Google Collaboratory is a cloud-based environment where we can run Python programs. So Google Collaboratory is very helpful for machine learning and data science projects. Okay. So if you are new to this Google Collaboratory and if you are not aware of how to use this, you can go to the second module, which is Python basics for machine learning. And if you go to this playlist, you will see this 2.1. So video index is 2.1, and it is on Google Collaboratory for Python. And in this video, I have explained detailedly about Google Collaboratory, on how to use Google Collaboratory and how to use the various features of Google Collaboratory. Okay, so you can watch that video. So now let's get started with the coding part. So here there will be a connect option. So before running any codes, you need to connect your system here. Okay, so once you connect your system, you will see this green tick mark. So now let's start the programming part. So the first step in any Python program is to import the dependencies. So you can make text here in Google Collaboratory. So you can just do some description, make some description about what you're doing in that particular code. So in this, I'll just make a text as importing the dependencies. Okay, so dependencies are nothing but the libraries and the function which we need for this particular project. So let's import some basic libraries such as NumPy and Pandas. So I'll import NumPy as NP and Pandas as PD. So I'll explain you what is the use of these libraries once I complete this particular cell. So let's import Pandas as PD, and let's import matplotlib. So import matplotlib.pyplot as plt, and import cbon as SNS. Okay, and then I need to import from sklearn dot model selection, import train test split. Okay, and then from XGBoost import XGB regressor, and from sklearn import metrics. So these are the dependencies that we need. Okay, so we have created the cell. Now in order to run this cell, to execute this cell, you can press shift plus enter. So when you press shift plus enter, it will run this cell and automatically go to the next one. So you can press that. Okay, so first of all, let's try to understand these libraries. So numpy is the library which is used to make arrays. So arrays are nothing but list of numbers or list of values, and it is very useful for our processing. So I'm importing numpy library, and I have imported numpy as np. So it is just a short form for numpy. So when you mention this as, so instead of using this numpy, we can just use this np. Okay, so it is just an abbreviation. So every time I don't need to mention numpy, I can just mention np. So this is the general convention that everyone uses in machine learning, where we import numpy as np. And so as I told you earlier, it is used to make numpy arrays. And then we have this pandas library. Pandas library is used to make data frames. So data frames are structured tables. So if we load the data set we have into the data frames, it will be easier for us to analyze the data and to process the data. So that is the role of this pandas library, so which is to create data frames. So I have imported pandas in the short form as pd. And then we have this matplotlib.pyplot. So this matplotlib library is used for creating plots. So we have seen that we need to do some data analysis, right? So in data analysis, so we use some visualization libraries. So visualization libraries are like those which are helpful to make plots and graphs. So matplotlib library and cborn, you can see the cborn library here. So both these libraries are data visualization libraries which are used to make plots and graphs. And then we have this train test split function. So I've already mentioned in the workflow that we need to split our data into training data and test data, right? And we will split the data using this train test split function. And we are importing this train test split function from sklearn.model selection. So sklearn is one of the very important machine learning libraries, so that we will use. And after that, we are importing this XGB regressor. So we have seen that we will be using a XGBoost regressor. So I'm importing this from the library XGBoost. And finally, we are importing this metrics from sklearn. So this metrics is used to evaluate our model. So we measure some error values to check how well our model is performing. So for this, we need this sklearn.metrics. So these are the dependencies that we need. So as we have imported all the dependencies, now we can go to the next step. So the next step will be to data collection and processing. Okay, so I'll just make a text here as data collection and processing. So you can go to Google and search as calories burned prediction Kaggle. So Kaggle is those sites which host machine learning and data science competition, and it also has a lot of data sets. So this is the data set which we are going to use. I'll give the link for this particular data set in the description of this video. So it will take you to this link from where you can download the data set. Okay, so this is the data set that we are interested in. So you can see here we have two CSV files. Okay, so one is calories and the second one is CSV. Sorry, the second one is exercise.csv. So you can just see this preview of this data set. So we have the columns, we have our user id. So we have some identification number for each value. So each row represents values of a person. So like first value represents the data for one person, second value represents the data for another person, and so on. So we have the user id, the identification number for each person, and we have gender, whether the person is male or female, and we have the age of that person, and we have height and weight of the person, and duration, so duration of the exercise they are doing. So this value is in minutes. Okay, so the duration on which they are doing the exercise, and we have the average heart rate. So I have already told you that the normal heart rate is about 75 beats per minute, and when we are doing it reaches 100, and it also will be greater than 100 at times, so per minute. So it is the average heartbeat during that duration. So here you can see the values are in the range of hundreds, right? So this is the heart rate, and then we have this body temperature values in Celsius. So the normal body temperature is around 36 and 37 degrees Celsius, and we know that the temperature will increase when we do exercise. I have already explained you. So we can see here the values are around 40 and 41, right? So this is the data set we have. So using this particular data set, we need to find the calories burned. So you can go to this calories.csv. So it contains the same user id. Okay, so you can just check this user id. It contains the same user id as those are present in this exercise.csv, but it just contains the calories burnt value. Okay, so you can see here, so this is the user id and this is the calories burnt value. So we need these two data sets and we need to combine these two data sets. Okay, so what you can do is go to this calories.csv. Now you can download this calories.csv file and then go to this exercise.csv, and from this download option you can download this file. Okay, so we will be using these two files, and once you download these two files, go to your Google Colab and you can find this files option here. So you can click here, and there will be an option called as upload to session storage. Okay, so if you click this, you can upload your files from your computer to this Google environment. Okay, or you can just press right click here. So there will be this upload option where you can upload the two CSV files. So you can see here I have already uploaded my calories.csv file and exercise.csv file, and we will be using this for our processing. Okay, so just a second. Okay, so now let's see what we can do with this data set. As I've told you, we need to use data frames for analysis and processing. So that's because you can see here the values are in the form of a CSV file. So CSV is nothing but comma separated values. So comma separated values means all the values are separated by commas in this particular file. So you can just open this CSV in a notepad and you can just see the data, and all the values will be separated by comma, and we cannot analyze the data when it is in the CSV file. So we need to load this data from the CSV file to a pandas data frame. Okay, so that's why we have imported this pandas library. So I'll just make a comment here as loading the data from CSV file to a pandas data frame. Okay, so let's name the data frame as calories. So calories is equal to PD. So PD means pandas library, which we have imported in an abbreviated form. PD dot read CSV. Okay, so you can see here this read CSV function will help us to load the data from CSV file to a pandas data frame. So inside this parenthesis mention quotes, and inside this quotes we need to paste the path of the file. So first let's take this calories.csv file. So you can find this options menu here. So there you can copy the path of the file and just put it in these quotes. Okay, so now you can press shift plus enter to run this cell and go to the next one. So this will execute the cell and this data will be stored in the pandas data frame. Now we can check the preview of the data frame. So what we will do is print the first 5 rows of the data frame. So let's get the sample of our data frame to see what are the features we have. For that you need to mention the data frame name dot yet. Okay, so this yet function will print the first 5 rows in our data set. So we know that this calories.csv file has user ID and calories column, right? So these are the first 5 rows we have, and you can check the values in this calories column. Now we need to do the same for this exercise.csv. So we need to load this exercise.csv to another data frame. After that we can combine both of them. Okay, so here I'll copy the path of this exercise.csv, and let's create another data frame as exercise data, which is equal to pd.readcsv. So we know that this readcsv function will load the data frame from CSV file to a data frame, right? So I'll just paste the path here. Now let's try to print the first 5 rows of this exercise data. So mention the data frame, which is exercise data dot ed. Let's see. Okay, so now we can see the first 5 rows of this exercise data, and it contains all the values here. So it contains this user ID, gender of the person, age, height, weight, duration, heart rate, and body temperature. So these are the parameters which we will use to find the calories burnt. Now you can get a doubt like we are just predicting the calories burned based on the duration on which they are doing exercises, right? And we can say that a person is going for a walk for 30 minutes. Okay, and we are calculating the number of calories burnt, and there is another person who is going a jog for 30 minutes. So we definitely know that the amount of calories burned by the person who is jogging will be more than the person who is just walking, right? Because like more energy is needed when you are going for a jog or when you are running, and when you are doing some heavy lifting, the amount of calories will be far more larger than that, right? So now you may get a doubt that what if that varies with the the exercise that we are doing. So let's think like this. So we need to distinguish between the calories burnt in different exercises. Say for example, when the person is going for a walk, the calories burnt will be less. When a person is running, the calories burnt will be more. And when a person is doing some heavy lifting, the calories burnt will be more even than the jogging, right? So now you may get a doubt that how we can do a prediction without that exercise, right? So you may get the doubt. Now let's try to understand this data set better. You can see the heart rate here. So when a person is going for a walk, the heart rate won't be that much high and the body temperature won't be that much high. And when a person is going for a jogging, of course the heart rate will be more, and when he is doing heavy lifting, the heart rate will be even more, right? So we can distinguish the exercise based on these values. So what I'm trying to tell you is there is an indirect relationship between the heart rate and body temperature with the exercise that they do. So let's consider two cases. So you can see here, so there is like two durations here. So one is 10 minutes and the another one is 13 minutes, where the heart rate is around 100 and here the heart rate is 81. So it can tell us that this person, the data point 4, in this case the person is doing some light exercises. So we can say that that person is just going for a walk, and that person's heart rate is around 81 beats per minute. Whereas in this case we can say that that person is doing more intense exercise, that's why their heart rate is more. So this is an indirect measurements or indirect inference that we get based on the exercises. So what I want you to understand here is, so this heart rate is an indirect measurement of the intensity of the exercise that they are doing, and based on this we can find the calories burned. So this is the idea behind it. Okay, so the next thing which we need to do is combine this calories value with this exercise data. Okay, so it's not of useful when we have this data separately. So what I'll try to do is I'll just take this calories data frame, and I don't want to combine this user ID because like you can see here, both of these user IDs are same because they are data of the same person. So I want this calories column alone. I want to put this calories column beside this body temperature column. So now we can see how we can do that. So I'll just make a text here as combining the two data frames. Combining the two data frames. Okay. So let's create a new data frame as calories data. Okay, so this is the data frame that has both this exercise values and the calories burnt values. So calories data is equal to PD, which is pandas.concat. So concat refers concatenation, which means to join something. So we need to concat two data frames. So the first data frame is exercise, right? So exercise data, and the second data frame which we need to join is this calories data, right? So mention, so the name of this particular data set is calories. So the C should be in small letter, so it shouldn't be in caps. So calories, and in this calories I don't want this user ID, I just want this calories column. Okay, so now you can just mention a square bracket here. Okay, so inside this square bracket mention the column name, which is calories. So here C is in caps, right? So you need to put the column name here, but we need to enclose it in quotes. So what I'm doing is I'm taking this exercise data, and with that exercise data, and I'm combining this calories column of this particular data frame. So that's what I'm doing here. And we need to mention another parameter here, which is okay. So we need to enclose this in a square bracket as well. So in this square bracket, we need to mention the two data frames, and after that, we need to mention the parameter axis is equal to 1. So axis is equal to 1 means in pandas, 1 refers to column and 0 represents rows. Here we need to join the data frames column wise, right? So I want to put this column beside this column. So we are using this axis is equal to 1. Let's say that we have two data frames and we want to add those data frames row after row. So in that case, we will mention axis is equal to 0. In that case, let's say that we have 5 values here, so 5 rows here, right? And we have 5 rows here also, and if we mention axis is equal to 0, all those rows from the second data set will be added after this row. Okay, whereas if you mention axis is equal to 1, data will be added after the last column. Okay, so that is the difference between axis is equal to 1 and 0. So 1 represents adding data column wise, and axis is equal to 0 represents adding data row wise. So let's run this, and now you can print the first 5 rows of this data frame. So this data frame is nothing but calories data. So this is the new data frame we have, which is calories data dot yet. So we can print this, and now you can see here the exercise data and the calories data. So both of these data frames are joined. So this is how you can combine these two data frames. Okay, so now let's try to understand more about this data. So let's check how many data points does this data frame has. So I'll just make a text here as checking the number of rows and columns. Okay, so for this, mention the data frame name calories data dot shape. So this shape function will give us the number of rows and columns we have. Here we can see that we have about 15,000 data points. So it is a good data set size. So like for example, like in machine learning, we deal with data set around this magnitude, and when it comes to deep learning, we can train our neural networks with data set that are that contains rows of like 1 lakh or even more than those data points. Here we have about 15,000 data points, and it is a very good size. Okay, so in some cases the data points will be very less, like we will be having only 500 rows or 600 rows, whereas here we have 15,000 data points, which is a good number of size. So we have 15,000 rows, that means data points for 15,000 different people. So each row represents different people, and we have totally for 15,000 people, and we have 9 features or 9 columns. So the second number represents column and the first number represents rows. So the 9 columns are user ID, gender, age, height, and all these columns. So totally we have 9 columns. So this is the shape of our data frame. And now let's try to get more information about our data set. So this step will be to getting some informations about the data. So mention the data frame calories dataset dot info. So let's run this. So this will give some important information about the data frame. So it can tell us the number of entries. So the number of data points we have, which is 15,000, and the number of columns, which is 9 columns, and you can see the number of non-null values. So null values means missing values, and non-values means the values that are present in the data set. So out of 15,000 data points, we have all the data points is filled, and we don't have any missing values. So that means this non-null count. And we also have the data type of each column. So you can see this integer, 64-bit integer. So this is user ID is in the form of integer, right? That's why. So object, so you can see that the gender column is object because it is in the form of text, whereas the other values are in the float 64. So floating points is nothing but, so these are 64-bit floating points. So floating points are nothing but decimal. So we can see that these values are in decimals, right? So this is what you can get when you use this dot info function. So this is very helpful to check for missing values. So there is also another method through which you can check the number of missing values. So I'll just show you, because like this particular line is very important. So checking for missing values. So calories data dot is null dot sum. So I have told you null values means missing values, right? So calories data dot is null dot sum. So this will give us the number of missing values we have in each column. So here we can see that we don't have any missing values though. So the missing values in each column is 0. That means we don't have any missing values, which is a very good thing. If we have missing values, we need to process those missing values before giving it to our machine learning model. So for that, we use methods like imputation, where we will replace the missing values with values such as mean, mode, median, etc. So we have already made a video on handling missing values in my channel. So to see that video, you can go to the fourth module, which is on data pre-processing and collection. So in that, I have explained you detailedly about how you can handle missing values in a data set. So here we don't have any missing values, which is a good thing. So we can continue our process. So the next thing which we will do is, let's get some statistical measures about our data set. Okay, so this particular step in our project will be on data analysis. So we have already discussed that we need to analyze our data to get more understanding, right? So this part will be data analysis. So okay, now what we can do is, so I'll just make a comment here. So I want to get some statistical measures about the data. Statistical measures about the data. So it helps us to tell what is the range the values are present in each column. So what is the mean value of each column? Say for example, what is the mean age of the people in this data set, and what is the minimum value, and some percentage values. So those values will be we can get from this particular cell. So calories data. So this is our data frame, and we need to use the function describe. So this particular describe will give us some statistical measures about the data. And you can see here, so we have this user ID column, so we don't need this user ID column. So we don't need the mean of user ID, and also it is just an identification number. So you can just skip this column, and you can see this age column. So we have the count. Count means the number of values we have. So we know that there are totally 15,000 different people, right? So there are totally about 15,000 values of age, and the mean value of age is about 42.7 is the mean value. So the mean age of that entire data set. And we have the standard deviation value, and we have what is the minimum age, and what is the percentile values. So percentile means like 25 percentile represents 25 percentage of the values are less than 28 age. Okay, so that means like in 15,000 you can count, or you can calculate the number of values for 25 percentage, and those many values are less than the age 28, and 50 percentage of people in this data set are less than the age of 39. So that is the meaning of this percentiles, and they are not percentage, so there is a difference between them. So similarly we have the maximum values. So we have these values for each column. So we have the height, so mean height of the people in the data set, and what is the minimum height, and this height value is in centimeters. So you can say it from the magnitude here. So 174 means centimeters. So you can see the height here, and we also have the mean weight, and minimum and maximum weight, and we also have the duration for which they have did the exercise, and we also have the heart rate. So here you can see the mean heart rate as 95. So I have told you already that the normal heartbeat will be from 70 to 80 in normal condition, in rest condition, and when we do exercise it will be kind of more. And we can see here the heart rate is kind of high, like it is about 95 beats per minute. So we can also see the body temperature here, and the normal body temperature is about 37 degrees Celsius, and here the body temperature is around 40, the mean temperature. That means the temperature is high in those people who are doing exercise, right? So in that time period in which they are doing exercise, the body temperature will be more. So this is the important inference we are getting, and we have this mean value of calories burnt and minimum and maximum values. So the important insights which we need to gain here is the heart rate and the body temperature will be more when the person is doing exercise. So this distinction is very important for us. So this is helpful for us to calculate exactly how much calories will be burnt during that exercise. Okay, so this is why this finding the statistical measures is very helpful. And now the next part will be to visualize the data. So I'll just make a text here as data visualization. So here we will try to put the data in some plots and graphs, and try to understand it better. So first what I'll do is, so I'll just run this sns.set. So this sns.set will give us some theme for our plot. So if you remember, we have imported the Seaborn library as SNS, right? So this sns.set will give some basic theme for our plots. Say for example, it will give some grid lines in our plots and the background theme in our plot. So that is the reason for this. So you just need to run this once. So now what I'll do is, so let's try to plot the different columns in our data frame. So first we have this gender column, right? So ignore this user ID column. So we don't need that. So we have this gender column, and let's try to find the distribution of this gender column. Like how many males are there in this data point, and how many females are there in this data point. So in this step, let's see. I'm going to plot. So plotting the gender column in count plot. So it helps us to find the distribution of males and females in this data set. So mention SNS, which is the Seaborn library, dot count plot. So this is a categorical column. So it contains values such as two categories, which are male and female, right? So this is an example of categorical column, and we can plot the categorical columns in count plot. So mention the data frame, which is calories data, and inside the square bracket mention the column name. Here the column name is gender, right? So now you can run this to find the distribution. So here you can see here the blue the data marked in blue color is represents male data points, and orange color represents female data points. And the important thing which we are getting here is the data point is almost similar, right? So you can see the size here, and we have equal distribution of male data points and female data points. So if we have just if one value is more, let's say that out of this 15,000, if we have only 5,000 values for female data points and 10,000 values for male data points, then that data set is not distributed in a good way, right? So now we have these two classifications or these two distribution where the value is almost similar. So it is around 7,000 for each data points or each types. So it is a very good distributed data set. So now let's try to understand or try to analyze the other values. So next we have this age column, height column, and weight column, right? So we cannot put this columns in count plot, because like count plots are very useful for categorical columns, and age is a categorical columns because it has only two values, either male or female. But we cannot do that in this case because age varies a lot. So we can have values all the way from 20 to 70, right? So we cannot put these values in count plot. So instead, we use a distribution plot to find which range of age has high distribution. So like what this means is, say in this example or in this data set, people at the age from 30 to 35, maybe more, and this can be found by using a distribution plot. So I'll just make this plot. You can get a better understanding of that. So I'll just make a comment here as finding the distribution of age column. Okay, so here we will be using sns.distplot. So distplot means distribution plot, and inside this parenthesis mention the column name, calories data, and the column name is ch, right? Okay, so let's run this. Now you can see the distribution here. So the x-axis represents the age of the person in the data set, and density means like how much data is present for that particular age. So you can see here we have more values in the range of 20 and 30, right? So you can see a peak in this curve. That means more values are present in the value of 20 and 30. That means in this 15,000 data points, more values are present in this range of 20 and 30, and the value is kind of decreasing. That means like people less people tend to come to gym at a older age, right? So that's the inference that we are getting, and we don't have much values less than 20. So this is how distribution, finding the distribution of the data is very helpful. So it tells us which range of values is more in this particular data set. Now let's try to find the distribution of other columns as well. So we have this height column, weight column, and duration, heartbeat, etc., right? So let's try to find all those values. So you just need to copy this particular line and just change the column name. So let's now check it for height. Okay, and I'll just replace this with height. Okay, so you can just check the column name here. So this column name should be exact. If the value is in caps, you need to put caps, or if the letter is in small letter, you need to put in small letter. Okay, so now let's check the height distribution values. Okay, so now you can see a normal distribution. So more people are present in the height of 160 and 8, and people who have a very less height are very less, and more height is kind of also less. So we have a normal distribution. So like there is the age or height value is not that much one-sided. Okay, so we have a normal distribution. And now let's check this for weight column. So I'll copy this, and you can copy this weight column here and replace the value here. Okay, so when you see it, we can find similarly the distribution of weight, and we have more people in the weight of around 60, and we also have some increased value in this between this 80 to 100. So this is how you can find the distribution of various features in a data set. So similarly, just try to find the distribution of other columns such as duration. So what is the duration they are doing, and what is the distribution of this heart rate data and other columns. Okay, so it will be of very interesting to see you the distribution of the data. So you just need to copy this line of code and change this weight to duration or heart rate, etc. So it will be a similar step. So after that, now what we will do is we will try to find the correlation between the data. So I'll explain you in a minute what is meant by this. Finding the correlation in the data set. So I'll just create a variable as correlation, which is equal to mention the data frame, which is calories data dot corr. So corr means this is the function that helps us to find the correlation value. So let's run this. So there are two types of correlation. So the first type of correlation is nothing but positive correlation. So I'll just put it here, positive correlation. And the second type of correlation is negative correlation. So what is meant by this positive correlation and negative correlation? Let us come to this data. So here we can see here, we can tell that if the duration for which a person is doing the exercise is more, then the number of calories they burnt will be more, right? So these two values are directly proportional, duration and calories. If the duration increases, the calories burnt also increases. If the duration decreases, calories burnt also decreases. So both of them are in the same direction. So that means these two features, these two columns are positively correlated. And if there are columns where if one column increases, the other column decreases, that means the two values are negatively correlated. So that is meant by this correlation. It is nothing but the relationship between the two features. Okay, so this is why finding the correlation is very important, because it tells us which columns are positively correlated and which columns are negatively correlated. Where positive correlation is something where two features will increase. If one feature increases, the other feature also increases. In that case, it is positively correlated, and it will be calculated by this .corr function. Just a second, I'll just check whether it's recording. Okay, so correlation is equal to calories data dot core. And now let's try to construct a heat map to visualize this correlation value. So constructing a heat map to understand the correlation. Okay, so plt dot figure. So if you remember, we have imported this matplotlib library, right? So I have imported this matplotlib library as plt. So we are going to use this library, and inside this we need to mention the figure size. So fig size, which represents the size of the plot, and let's put 10 comma 10. So it is just the size of the figure. You can just put any values you want. So less values means the plot will be smaller, and if the value is high, the graph will be larger. Okay, so plt dot figure and sns dot heat map. So we need to construct a heat map, and inside this we need to mention some parameters. So let me complete this first and explain you what is meant by these values. So first is correlation c bar, which is the color bar, true, and square is equal to true. And next we need to include fmt is equal to dot 1f 1f. So just give me a minute, I'll just complete this. Annotations is equal to true, and kws is equal to size. So size should be enclosed in quotes. Let's make the size as 8. And C map. So color of the map, let's take blue color. Okay, so blues. And finally we can run this. I'll explain you what is meant by this heat map. So we can see a color map here. So heat map gives values based on, gives colors based on the values. So we have the values from 0 or 2 1. Okay, so 0 means the lowest value and 1 means the highest value, and this value is calculated based on the relationship between the data. So the relationship between this various features. So you can see the column names here. So user id, age, height, weight, etc., and you have the same columns here. So now each column will be compared to the other columns, and if the value is larger, if the value is 1, then that means the two columns are positively correlated. If the value is very less, that means the values are negatively correlated, and if the value is 0, that means there is no correlation at all. Let's now try to understand this. So you can just skip this diagonal. So we don't need to see this diagonal, because like both of these columns represent the same values. Here you can see here this is user ID, and here it is this, in this x-axis it is the user ID, right? So that's why it has this value 1, and then you can see here the second column is age, and it is also age. That's why this particular diagonal is of the value 1. So you can just ignore this. Now you can see the other positively correlated column. So you can see here height and weight have a correlation of about 1.0. So it is a, if you think logically, we can tell that if a person is very taller, then that person's weight will also be kind of more, right? So that's the inference from this height and weight correlation. The important correlation that we are interested in is how much this duration and calories burnt are correlated, how much the heart rate and the calories are correlated. So we know that if a person do exercise for a long time, then is more probably going to burn more calories, right? So that's why this duration, and you can see in this axis like calories, so the calories value is highly positively correlated. So if duration increases, the calories burned will also increase, and these values are also correlated, because like when a person do exercise for a more time, then they are going to have a increased heart rate, right? So that's why this heart rate is correlated with the duration, and it also similar in the case of body temperature also. So that's why these three columns, which are duration, heart rate, and body temperature, are positively correlated with this calories value. And this is how we are going to find the calories burned. So this is just to understand what is the relationship between the various columns in our dataset, where we have found that the height and weight are positively correlated, and we can say that the duration, heart rate, and body temperature are highly positively correlated with calories. So that means higher duration of exercise will ensure that more calories will be burned, and it also ensures that the heart rate will be more, and if the heart rate is more, then more calories will be burned, because that person is more likely to do more exercise. Okay, so this is the correlation that we are getting. So now what we will do is, so next we can split our data set into training data and test data. After that we can feed it to our machine learning model. Just there is one more step which we need to do in our data set. So I'll just come to this data frame here. You can see this gender column. So all the values in our data frame are in the form of numerical values, right? So age is in the form of numerical value, height, weight, duration, everything is in the form of numerical values. But this gender column is in the form of text. So it is, the value is either male or female. So we cannot feed this text data to our machine learning model. So computers don't understand text better. So we need to replace these values with appropriate numerical values, so that the machine can understand. So what I'm going to do here is convert. So wherever there is this value as male, I'm going to replace male with 0, and I'm going to replace female with 1. So this becomes categories, right? So this column will then contain values as either 0 or 1. So it will ensure that this column also contain values in the form of numerical values and not in the form of text. So this step will be to convert. So I'll just make a text here as converting the text data to numerical values. Okay. So this is called as categorical data encoding. So mention the data frame name, which is calories data, and we need to use the function called as replace. So this replace function will replace the values of male and female. So we need to mention it here. So calories data dot replace, and inside this just open a curly bracket, and we need to mention the column name, and the column name which we are interested in is gender, right? So the gender column. And another thing, so this is in the form of categorical column, and those categorical columns won't be included in this correlation map. So that is one thing which I failed to explain you. So that is gender column. Okay, so I forgot to tell you that here. So when you find the describe also, so here we have found this describe, right? So we found some statistical measures, and we don't have this gender column here, because we cannot find a mean value for a text value. We can find the mean and standard deviation only for numerical values. That's why we don't have the text data here. So this gender column is ignored here, and similarly the gender data is ignored in this case, because we cannot find correlation between a categorical column and the target variable. Okay, so calories data dot replace, and inside this mention the column name, which is gender, and we need to replace the values, where we will replace all the values of male as 0 and female as 1. Okay. Now let's mention in place is equal to true. So let's run this. So what happens here is I'm just taking this calories data and I'm replacing the values. So I'm using this replace function, right? So I'm replacing all the values in this gender column. And how I'm replacing is I'm taking the male values and I'm replacing all the male values with 0 and I'm replacing all the female values with 1. So this is what we are doing here. And we have this another parameter called as in place is equal to true. So in place means like I want to change this as a permanent change. So if you don't mention in place is equal to true, so the values will be changed only for this particular output of this cell. So if we mention this in place is equal to true, this change will be carried out throughout. Okay, so this is just to retain that particular replacement. So let's run this. Okay, so we have some error here. Okay, so calories data. So I'll just see what has happened here. Male female is equal to 1, calories data dot replace gender male. mm, okay, it's nothing if you just print this line again. Calories data dot date. You can see here the value has been replaced. I don't know why, but we are getting this error even though it has converted the values. It is just giving this error, so it is not of that that of an issue. So I'll just go to this runtime and restart and run all the codes. So I think we won't get that error now. So this error is not that significant because like I think this time it will be corrected. So let's see. Yeah, okay, so I haven't changed anything here, so it is everything is, I'm saying, so everything is same. So I'm just running this again. So now you can see here now the male value is replaced by 0. So you can go to this particular gender column. So this male value will be replaced by 0 and female value will be replaced by 1. And here you can see here how the replacement is happened. So if I think you will also probably find this error if you run the code. So what you do is just after you have replaced this, just try to print the first 5 rows of the data frame, and that error won't be there. So the value will be replaced. Just go to this runtime and give restart and run also. Your session will be replaced and all the cells will be all the cells will be executed again. So it is not a big of an issue here. So now what we will do is let's separate the features and the target. Here the target column, the target which we are interested in is calories, right? So let's separate this calories column and other columns. So other columns are called as features and this calories column is called as target. So I'll just make a text here as separating features and target. Okay, so let's take two variables. One is x and the another one is y, and mention the data frame calories data. And here we are going to drop some values. So I just want all those features and not these calories, right? So I'm going to drop this calories column, and also I'm going to drop this user ID column because we don't need this identification number. So it is of no use for our particular training. So training the machine learning model. So let's drop this user ID column and calories column. So this calories data dot drop. So this drop function in pandas is used to drop some columns in our data frame. So drop, mention the column names which you want to drop. So columns is equal to, so I'll just create a square bracket and mention the columns which are user ID because I don't want the user ID column as well. And the second column which I want to remove is calories. Okay, so now I'll mention axis is equal to 1. So I have already explained you that axis is equal to 1 represents column in pandas and axis is equal to 1 represents rows. In case if you want to remove a column, we will mention axis is equal to 1, and let's say that we want to remove this fifth row. So in that case we will mention axis is equal to 0. So 0 means row and 1 represents column. Now what happens is x will contain all the columns except this user ID and calories. Okay, now what I'm going to do is store this calories column in this y variable. So mention calories data. So calories data, and inside the square bracket mention calories. Okay, so what we are doing is taking this gender, age, height, weight, duration, heart rate, and body temperature in x, and this calories column alone in y. Okay, so let's run this. Now you can print this X and Y. So this X won't contain user ID and calories column. So you can see here it only contain these from gender column to body temperature column. So this user ID and calories will be removed. When you print Y, it will contain only the values of calories burned. So this is how you can split your features and target, because like we need to split this data before splitting our data into training and test data. So it is one of the important steps that we do. So we need to separate features and target. So as we have successfully splitted it, now we can split our data into training data and test data. So splitting the data into training data and test data. Okay, so for this we need to create four arrays. So they are xtrain, xtest, ytrain, and ytest. Okay, so what are these four arrays? So let's say that we have this x and y, right? So I'm going to separate this x as two arrays. One is xtrain and xtest. So xtrain represents all the training data and xtest represents all the test data. So we know that we will be using the training data for training our machine learning model, and test data will be used to evaluate our model. So this x will be split into two. One goes into the training data and the other set goes to the test data. Now the corresponding calorie values, the corresponding y values will go to y train, and the corresponding calories value for test data go to y test. So it is very simple to understand. So we have four values. So x train contains all the training data for x, and x test contain all this data for test data, and the corresponding calories value for x train will be stored in y train, and the corresponding calories values for x test will be stored in y test. So that's what we are doing. Okay, so we are just splitting these two x and y into training data and test data, and for this we are going to use the function train test split, which we have imported from sklearn.model selection. So you can see here, right? So train test split, and inside this we need to mention some parameters. So the parameters are x and y, because we are going to split this x and y, right? So we have already splitted it into features and target, where x represents the features and y represents the target, and we are splitting it based on x and y. And just there is another two parameters, so just mention this test size is equal to, let's put 0.2. So test size is equal to 0.2, so 0.2 means 20%. That means I want 20% of the data as test data and 80% of the data as training data. So generally we take 10% or 20% of the data as test data. So it is the general convention, and 80% or 90% of the data goes into the training data. Here I'm just taking 20%. Okay. So there is another parameter which we can mention, which is random state is equal to 2. So random state is just to reproduce the code. So when you use this train test split function, your data will be splitted in an automatic manner. So there is not any general manner in which your data will be splitted. But when you mention this random state, so random state, I'm mentioning this random state is equal to 2. That means my data will be splitted in a specific manner. And let's say that you are practicing this code and you also want to split the data in the same manner that I did. In that case, we both need to mention the random state is equal to same number. If you mention random state is equal to 3, then your data will be split in a different way. If you mention the random state is equal to 2, then your data will be split in the same way that my data is getting splitted. So this is just to have the similar splitting of data. So let's run this. Okay, so now let's try to print the shape of all this data. X dot shape, x train dot shape, and x test dot shape. So here you can note that for every function we will use parentheses after. Like for example, for id function, so you can go to this id function, we have used parentheses. But in the case of shape, we won't use it because it is kind of a tuple, and we don't use parentheses after this shape function alone. Let's run this. Here x represents the original data, and x train represents the training data, and x test represents the test data. So the original data set, we have about 15,000 data points, right? So that is the shape of x, and x train contains 80% of original data, and 80% of data is 12,000, and x test contains 20% of data, which is 3,000. So this is how you can split your data into training data and test data. So now the next part will be on model training. Okay, So as I've told you earlier, we are going to train a XGBoost Regressor model, right? So I'll just make a text here as XGBoost Regressor, XGBoost Regressor. So I won't be going in detail about what is the math behind this model and how this model works. So I'll be explaining you this in a different video. So it is out of scope of this particular video. So the idea of this video is just to show you the implementation of this particular project. So I'll be making videos in the future modules on what is meant by these models and what is the math behind this model and how we can build these models from scratch. So that will be covered in a different module. For now, let's see how we can implement this. So if you remember, we have imported the XGBoost regressor. So you can see here XGB regressor from XGBoost. Now I'm going to use this XGB regressor. So I'll just copy this, and now we need to load the model. So loading the model, let's create a variable as model, and inside this model let's load our XGB regressor and mention a parenthesis here. So this means we are loading one instance of XGB regressor to the variable called as model. So just press shift plus enter. So this cell will be executed. Now this model will contain this XGB regressor. Now we can train this particular model. So training, we know that we need to train our data with the training data, right? So training the model with xtrain. Okay. So I'm using this model, which is model. For training, we need to use the function model.fit. So when you use this model.fit, we need to mention the training data, which are xtrain and ytrain. So we know that we have splitted the data into xtrain and xtest, where x represents the features, right? So xtrain is the training data features and ytrain is the calories for that data. So it is just giving an x-axis and y-axis, where x-axis is the features and y-axis is the ytrain. So when we run this model.fit function, it helps our model to train. So this part is called as model training. So when you give this data to our XGB regression model, it finds the pattern between the data. Say for example, it can understand like if the duration is more, then the number of calories burnt will be more, and if the heart rate is more, also the number of calories will be more, and those things will be learned by our model automatically. And that's what we are doing in this model.fit, where we give this x train and y train. So you can just run this model, and these are the parameters which we have for our model. So now our model has learned from the data. Okay, so now we can evaluate our model. So this doesn't take much time. But when you are working on deep learning and when you are working with a very large data set, so we can also work with data set that contains a lakhs of data points. So in that case, the training will take a long time. So this is just a numerical data set, right? If we work in image data set and audio data sets in case of deep learning, the training time will be very large. So it can also take days and weeks for training a model. So this is a very simple data set. So it doesn't take much time. So as we have trained our model, now we can evaluate our model. Okay, evaluation. So I have already explained you that we will train our machine learning model based on the X-train, that is the training data, and we will test our data or evaluate our data based on our test data, right? So now let's just evaluate our model based on the test data. So I'll just make a text here as prediction on test data. Okay, so you can also find the prediction on training data as well. So there is nothing wrong in that, but I'll just find the prediction on training on the test data alone. So training data prediction, sorry, test data prediction. Now what I'm going to do is, so we know that we have trained our model with X train and Y train. So Y train is nothing but the calories value. And now I will just give this Y train alone, and our model will find the number of calories burnt. Okay, and that will be compared with the original values. So sorry, I will give this X test. Okay, so I won't give this Y test, which is the calories burnt. So with this data, with this test data, our model can find what is the calories burnt, and we are going to compare that value with the original values, which is y test. Okay, so I'll just do this, you can understand it better. So test data prediction is equal to model dot predict. So this model is now a trained model. So you can see here model dot fit. So when you run this, your model will be trained, and I'm using the trained model here. So model dot predict x test. So I'm not giving the y test, which is the calories value. I'm just giving the features, the duration, age, gender, etc. So that values alone. So let's run this. So what happens is, now our model goes through this X test and find the calories burnt values for this X test, and all those values will be stored in this test data predictions. You can also print this and see print test data prediction. So this will give us the value. So these are the values of the calories burned. So like there is three dots that represents a lot of values are there in between. So this is the values of calories burnt, and this is how you can predict the calories burnt by giving those features. So these features are nothing but the age, gender, duration, heartbeat, and body temperature. So this is the values predicted by our model. Okay, so we have trained our model with X train and Y train, and we have found the values of X test based on our model. Now what we need to do is compare the values predicted by our model with the original values. The original values are nothing but Y test, right? Now we need to compare this Y test and this test data prediction. Okay, so for this we will be using a metric called as mean absolute error. Mean absolute error. So it will tell us what is the magnitude of error that our model is making. Let's take this 129. Let's say that the actual value for this 129 calories is like 135 calories. Okay, but our model is as predicted as 129, right? So this value will be separated, or will be subtracted, to be more precise. So 135 will be subtracted in this 129. The value we get is 6, right? So 6 is the mean absolute error our model is making. So you can consider this 39, and let's say that the model has predicted as 39 and the real value is 36. In that case, the difference is 3. So there is not positive or negative sign here. You just need to find the difference. So that is why it's called as mean absolute error. So in this case, the mean absolute error for this data point is 3, right? So similarly, we will find the the absolute error for all the values, and the error, we will take a mean for all the values and find what is the mean absolute error, the overall error that the model is making. Okay, so for this we will be using this sklearn.metrics. You can see here we have imported this metrics from sklearn library. So let's use this particular library. Now I'll create a variable as mae, where mae represents mean absolute error, and call this metrics module. So metrics dot mean absolute error. Okay, so mean absolute error, inside the parenthesis mention the original value, which is Y test, and the value is predicted by our model is test data prediction. I'll just copy this. Okay, so these are the two values, where Y test is the values, original values, and test data prediction is the values made by our model. Okay, so now let's run this to find the mean absolute error. Let's print it as mean absolute error. So this mean absolute error should be as low as possible, right? So it's nothing but the difference between the actual values and the values predicted by our model. Let's see what is the values we are getting. So I'll just put this MAE. So this will print our mean absolute error value here. So the mean absolute error value which I are getting is 2.71, which is a very good score. So the error value is very less, because like it means like if the original value is 131, let's say that the original calories burnt value is 131, then the model is predicting 129, and this is very close, right? Like the magnitude of 2 is very close, and there is not a general there is not any general value of mean absolute error here. That it depends on the magnitude of each value. Let's say that we are predicting the car prices. Okay, so let's say that car price is around 10 lakhs, and our model is predicting, and our model is making a mean absolute error of 1000. Okay, so 1000 or 2000 rupees. Out of those 10 lakhs, the mean absolute error of 1000 or 2000 is not very much. So in that case, the mean absolute error is actually good. But when you are considering price of a mobile phone, so let's say that we are predicting the price of mobile phones, and the price of the mobile phone is around 12,000 or 13,000. In that case, if our model makes a mean absolute error of about 1000 or 2000, in that case the value is very large, right? So the error is very large, so we cannot accept that kind of error. So it all depends on the magnitude of the values, and the magnitude of values we have here is around hundreds, 50s, right? So we have the values in hundreds, 200s, and in 40s, right? So in this magnitude, mean absolute error of 2 is very good actually, because like for 131 calories, our model can predict the value of 129. For 225, our model can predict a value of 223, which is very close. So in this case, a mean absolute error of 2.7 is 1 is very close. And what I want you to understand here is there is not a general thumb rule of what is the best mean absolute error. So it varies depending on the problem statement. It varies depending on the data which we are working. In our case, we have the values in the range of hundreds, and in the value of 100, mean absolute error of 2 or 3 is really good. So this is how you can evaluate our model. And you can also make a predictive system. You can build a predictive system. In my previous videos, I have explained you how you can build a system when you can, like, let's consider this case. When you give some input data, when you give the gender of the person, age, duration, and heartbeat, it can find what is the calories burnt. So we can also build some predictive system like that. So I'm not going to do that in this video. So I have already made several videos on how to build that predictive system. So if you want a reference, just go to the medical insurance cost prediction video. So in that, I have explained you in the final step on how to build a predictive system where you can just give the input data and find the value. So you can use the same method in this case, where you will be giving the input data such as gender, age, etc., and your model can predict what is the calories burnt calories burnt value. So that will be a very good exercise for you. So I hope you have understood all the things that we have covered in this video. So I'll just give you a quick recap of what we have done in this project so far. Okay, so the first step is about importing the dependencies. So we have imported some basic libraries such as NumPy, Pandas, and data visualization libraries like Matplotlib, Seaborn, etc. And we have imported this train test split function to split our data into training data and test data. And then we have imported our XGB regressor from XGBoost, and finally metrics for evaluating our model. So we got two data sets from our data, which is, so one data set file is on calories and the other dataset file is on exercise. And we have seen how we can combine these two datasets using this pd.concat. And after that, we have checked the number of data points we have, the number of rows and columns we add, and what is the general information of the data. And we have checked whether we have any missing values, and unfortunately we didn't have any missing values in our data. And we did some data analysis where we got some statistical measures of the data, and we have visualized some features in our dataset and found some distribution of our dataset. After that, we have find the correlation, so some positive correlation between the features and the negative correlation between the features. And then we have converted this male and female to 0 and 1. So we have converted this text value to numerical values. And then we have separated this data into features and target. So calories becomes our target, and the other columns are nothing but the features. And we have put it in x and y respectively. And we have split our data into training data and test data. And once we have split our data, we have trained our XGB regressor using the training data. And after that, we have evaluate our data based on the test data. So I hope you have understood all the things that we have did in this project. So if you have any doubt, please mention in the comments. So I'll just give you, I'll try to clarify your doubts. So that's it for this video. So I'll see you in the next video. Thanks for watching.